All right, my name is Bailey Carruthers, and this is my submission for Programming Project 1. Just some stuff to preface it. I went ahead and took the hex values for the two instructions given here, put them, instruction 1, instruction 2 from hex, converted them to binary, and labeled them accordingly. So, for example, like this is our opcode, RD, function 3, RS1, RS2, so on and so forth. And then since we have to take in two arguments and the second argument determines what field, I went ahead and converted the relevant fields as well. So say if the second argument is 0, we need the opcode field. The opcode field is these binary places. And this binary value converted to hex is 33. Same with RD and RS1. These are their values converted from binary to hex. Same with instruction 2, hex to binary labeled, and then the individual RD, opcode, and RS1 hex values relevant, and then some other stuff that I used. Since we only care about, so say, for instance, we want the opcode, we only care about these 7 places. So we need a mask with 7 ones on this end, and then all zeros here. That way we can AND the mask and the number, and we will only get what is in these places, which in this case would be like the opcode. And similar thing for when we want to find RD and RS1, we shift right until these values, however many, so like these 5 places are in the least significant bit spot, the first 5 numbers here, basically is what it would be. And then we mask it with this mask because this mask just masks, or it masks everything but the leading 5, essentially. So yeah, let's go over to the code. We have our extract fields function, our code, and then we have our just regular C. If we go ahead and run it. All right, so this was just from the examples that he gave. You can ignore that, it's all commented out. We declare a couple integers, but we don't assign them any values. And then we declare instruction 1, and we give we assign it, what our given value was for the project. And then, so I'm going to step into this one. And basically, so this is going to say instruction 1 with input 0, and that's what value is going to get assigned here. So what it's going to do is it's going to take us over to our extract fields. And what I opted for was loading the number 1 into this register, and same thing here, loading the number 2 into this register. And then we check A1, which in this case, A1 is the second argument passed in, instruction 1 being A0. And we compare A1, our second argument. And the first thing we do is we compare it to this register here. This register here is hardwired to 0. So we don't have to, it's hardwired 0, right, basically. So we check if A1 is 0. And if it is, we go to A0, which in this case it's going to be. Jumps to here. And then we load this mask into A2. This mask is basically, this is the binary equivalent of this mask, this hex mask. And then we can see that it's down here in A2 now, 7F. And then we AND our first input, which is A0, with the mask, which is A2, and then we store that into A0, and then we return. And when we return, we go ahead and print out the opcode, or we print out and say opcode here, and then this is just what we just assigned this. So opcode, the value of that in hex is 33, and opcode hex here 33, so we know that this in hex is 33, and it returned the correct opcode here. Similar for all the rest. Load our two registers for comparison. This time around, our second argument is 1, so we're going to get here, we're going to say, oh, it is 1, and it's going to jump down. We're going to load our other mask that masks, or that basically leaves us with the first 5 bits. And this time, we're going to shift right 7, which basically shifts the opcode out and puts the RD in the least significant spot. And then we run this mask over it. And so all we're left with is the RD value. Like I said, shift right, and then we AND the mask and that, and store it back into A0. If we print that out, we see RD9. RD, our hex value is indeed 9. That is that there. Same thing again. We get to here. Our second argument is 2, so we go to is 2. And we load our other mask, 1F, which is this mask here. Same thing. And then this time, we actually shift it 15. That way, we get the correct values as usual. So we shift, and then we AND, return. And then it prints out that our RS1 value is 14. Come back here, we can see RS1 hex is 14. Here's our RS1 binary. Can be verified that way. And then I'm going to go ahead and press play and run the rest of it. And we can see that for instruction 2, this is what we get. And opcode 33, RD10, and then RS1 is F, so we can see that everything lines up there. And that is, the code just exits after that. I did the exact same setup for the second instruction, declared a couple empty integers, and then my second instruction, and then ran those in with the different arguments 0, 1, and 2. And yep, that was it.